In this video, we will discuss how Cisco Meraki has redefined the management and configuration of switches. So let's get started. Let's take a closer look at some of the feature highlights. Delays beyond 150 milliseconds are often unacceptable for supporting voice and video traffic. Cisco Meraki switches support Layer 2 and Layer 3 quality of service, ensuring these real-time traffic flows are given priority as they enter and traverse the network. Set switch port to accept ingress prioritization label or for certain ports or VLANs to a chosen priority level. 6 queues with full QoS settings support flexible policy implementation. Layer 7 application visibility, previously available only through costly overlay appliances, is included in Cisco Meraki switches at no additional cost. Hundreds of applications are automatically identified and reported, from business app to BitTorrent and YouTube. Rather than separately managing each switch, switches can be grouped together into virtual stacks, regardless of how physically dispersed those switches may be. For high performance and management conveniences, switches can also be physically stacked together and managed as a single entity. OSPF routing algorithm automatically factor link cost to calculate optimal pathway for routing packet from point A to point B. This efficiency translates into improved network performance since delays across slow links are minimized. Network ports are all around us. Most are in physically secure environments, but many are not. Using 802.1x port-based network access control, MAC-based authentication, or a mix of the two, the network administrator can lock down access on a port-by-port basis to authorized user or devices. A guest VLAN can be configured to provide restricted access, perhaps to the internet via DMZ or a remediation server. Many internet network issues start at the physical layer. At a remote site, a cable connecting to a computer or phone may become damaged or in normal use. With built-in remote cable testing, the network administrator can test the integrity of the cable, even thousands of miles away. A cable test will also indicate the approximate length of the cable, helping the remote engineer understand whether they are working on a patch cable or building cable. Every network engineer knows that sooner or later only a packet capture will truly identify the source of a network problem. Cisco Meraki offers the unique ability to run a detailed packet capture from anywhere with an internet connection, without needing to be directly connected to the relevant switch. Simply select the port or device in dashboard and run the capture. This will generate an industry standard PCAP file, which can be opened with the usual software. Numerous models scaling from access to campus aggregation, including cloud-managed physical stacking, multi-gigabit performance, and universal power over Ethernet power for the campus network. MS switch models. Let's have a look on our Layer 2 access switch with the MS220. Comes in 8, 24, and 48 ports, integrated with power and fans, and also compatible with the Cisco RPS 2300. The MS225, which is considered as a 2.5 layer because of its ability to do static routing with 10 gigabits of SFP plus uplinks, and also has 2 stacking interfaces with up to 80 gigabits of stacking bandwidth. Moving to Layer 3 with the MS250, very similar than the MS225, however, it has also the ability to do dynamic routing and has hot swappable power supplies. The MS350 provides 160 gigabits of stacking bandwidth plus the ability to do hot swap power supplies and LAN fans. The MS350 24X has 8 multi-gigabit ports and the ability to provide 60 watts of power per port, also known as UPoE, or Universal Power of Ethernet. On the Layer 3 aggregation with the MS410, SFP and SFP Plus only switch has 2 dedicated stacking ports for a total of 160 gigabits of stacking bandwidth. The MS425 is an SFP Plus only and has 2 40 gigabits of QSFP uplinks and has the ability to do flexible stacking. Now, in regard of stacking, only like models can be stacked. For example, MS350-48 and an MS350-24X can be stacked, but MS250-48 cannot be stacked with an MS350-48. Physical stacking is available on MS225, 250, 350, and 410, which includes dedicated stacking port. Flexible stacking is available on MS425 switches which do not have dedicated stacking port. Any port of these switches can be configured as stack port. MS feature, multi-gigabit Ethernet. Gigabit connections have served us well for many years, delivering fast low-latency data to the PCs, phones, and other devices sitting on our desks. With rapid advances in wireless technology, the latest generation of access point can overwhelm a gigabit connection so that the wired network becomes a performance bottleneck. With the continuing trend towards wireless as the dominant medium, a technology was needed which could push past the long-standing 1 gigabit limit. Multi-gigabit is this technology, capable of delivering up to 10 gigabits per second to the most demanding IT equipment. 10 gigabit speed, and even faster, have been available over copper cabling for some time. However, these options are limited, either by the need for short cable runs, or the very latest twisted pair cable type Cat5/6A or higher. For many organizations, the cost of ripping out and upgrading cable outweigh the benefit, so Cat5e and Cat6 remain the prevailing copper technology installed today. Multi-gigabit technology bridges a gap between the 1 and 10 gigabit standard, adding options for 2.5 and 5 gigabits over existing cabling. Multi-gigabit technology is the collaborative work of the N-based T Alliance, a consortium of over 45 industry leaders formed in 2014. These efforts have combined into an emerging IEEE standard, 802.3bz, which will formally introduce 2.5 gig base T and 5 gigabit base T in 2016. Designed as an addition to the Meraki MS350 flagship layer 3 stackable access switch family, the MS350 24X has 24 ports, 8 of which are multi-gig capable and can support speed of 1, 2.5, 5, 10 gigabits on supported cable types. This switch perfectly complements the MR53 and MR84, which are multi-gig capable. MS feature, physical stacking. Managing switches is an essential part of the network administration. So with Cisco Meraki, there are no expensive feature or support licenses to pay for or no requirement for proprietary cable either. Large network can be assembled using a combination of standalone, physically stacked, and aggregation layer switches. Redundancy is supported in hardware and software with hot swappable power supply and fans plus link aggregation and warm spare functionality. With up to 8 stacked switches per wiring closet, all of which are managed through a single pane of glass, the Meraki dashboard. The dedicated stacking cable between switches in the stack provide up to 160 gigabits of stack bandwidth with spatial reuse and link up to the core distribution layer. By using cross-stack LSCP, throughput between network layer is maximized and all links are forwarding. MS feature, virtual stacking. Virtual stacking is a concept pioneered by Cisco Meraki. MS series switches can be treated as a virtual stack without requiring a physical connection and regardless of their location. This means that switches can be in different physical locations. For instance, you might have one switch in New York and another switch in California. An administrator still have unprecedented visibility and manageability in all the ports of the virtual stack, greatly simplifying management of large distributed networks. Switches that are in the same physical location can be physically stacked and managed using virtual stacking in the same way. Leverage the power of centralized cloud management to pre-state switches and virtual stack before they are even deployed. Using this approach, switch deployment becomes a zero-touch, plug-and-play exercise, even by non-technical staff. Bug changes and software updates are straightforward to push out, eliminating the requirement to be physically present at each switch or stack. MS feature, topology. Network topology automatically maps network architecture, showing how Meraki security, switching, phone, cameras, and wireless devices are connected, including redundant link disabled by the spanning tree protocol to prevent data loops. In the topology view, square represent MX security appliances, rectangle represent MS switches, and circle represent MR access point. Non-Meraki equipment is also detected and displayed, because Meraki MS switch automatically listens for LLDP and CDP broadcasts from connected devices. it may be possible to detect the manufacturer, model type, IP address, and more on the third-party equipment. This is done automatically with no overlay software needed. Quickly zero in the device that matter by using the dynamic search tool available in the topology dashboard view. Search for network device by name, tag, or device type to see how equipment is deployed. Devices not meeting search criteria will be automatically dimmed, so that sought for equipment is highlighted. Conversely, if you are viewing detail for a specific client, like a laptop or a mobile phone, from within the Meraki dashboard, clicking the topology link will highlight which network device that client is directly connected to, enabling a quick assessment of upstream connectivity. See at a glance where trouble lies on your network. Devices displayed in the topology view are color-coded based on connectivity health. Meraki devices alerting red or yellow can be immediately clicked into for remote diagnosis and troubleshooting. Hovering over individual network links displays the active port of each termination point, the number of clients using that link for the last day, link speed, and link usage. These statistics make it easy to pinpoint which links are the most heavily trafficked and service the most clients.